So here we are today, and today is review day, and I'm going straight to the point with the review. Okay, straight to the point with the review. The final exam will consist of 10 questions, and those questions will relate to the topics we've looked at. I'm going to show you the topics we looked at and sample questions today that will be almost identical in terms of format to the final exam. So here today, this is a good preview. I'm hoping this is a good preview anyway for the final. So what I'm going to do is I'm going to hop now to get me off the screen, and I'm going to put this thing up on the thing. And yes, it is working. Okay. I'm running out of colors. I got to start all over again after Christmas with law, and I'll come up with new colors. Anyway, so here we've got this spiel of stuff that I want you to be familiar with for the final exam. Now, all of this spiel of stuff is really applying the concepts that we've looked at in the first unit. The exam, as same as the midterm, it will have formulas on it. Okay, and your task on this exam is to work through some questions, 10 questions. So what I've got here is a sample of the types of questions that you will find. Okay, now where does this sample come from? This sample comes directly from the review sheets that are in the course. So what I want you to do over the next few days, because next few days will be study days for you, is to look at those review sheets that are at the end of all of the units. You can see review and the answers are there for them, and I want you to work through them. That is how you study for this exam. Okay? First one, annuity. Annuity. Dave wishes to retire in 25 years with $500,000 in his RRSP. How much would he have to invest each quarter at an interest rate of 5.65% compounded monthly? And how much interest will Dave earn? Well, first of all, you got to be able to tease the key components out of this type of question. Okay, 25 years is the time frame. 50,000 is the 500,000. Sorry, is the future value that you want to look at. The investment is made each quarter, meaning 4 times a year. So 4 times a year for 25 years, 4 times 25 is 100. So from the point of view of figuring out how many compounds we have, or how many payments we'll have, 25 times 4 is 100. The interest rate is 5.65% compounded monthly. So what you need to do is to figure out what is the monthly interest rate. So 5.65 needs to be divided by 12 in order to get the monthly rate. That will give us the value I. We're also noticing that the rate is compounded monthly, but the investment is quarterly. So we've got a situation where the compounding and the payments are different. Now this is a good sign of an ordinary general annuity. Okay, so this is an ordinary general annuity. There's no indication that they're made at the beginning of the month, so it is an ordinary general annuity. It's not an annuity due. So what we need to be able to do then is to work through the calculation for an ordinary general annuity on this, given the information that we have. The payments per year is 4, and the compounds per year is 12. So what we got to do is take compounds, divide it by the payments per year, and that will give us a value of C, which would be 12 divided by 4, which would be 3. I have, instead of sitting with you and working this out now, I'm going to go through this and show you the mechanics of it, okay? So the first thing I would like you to do whenever you answer this type of question is to draw out a timeline. So it's 25 years time, and at the end of that 25 years, there's $500,000. 5.65 compounded monthly, so that's 12 compounds a year, and there's 4 payments a year. So N is 100, where it's 25 years, 4 payments per year. Calculate the value of C. As I say, C is compounds per year divided by payments per year. That's 12 over 4, which is 3. And we can use that 3 then, the value of C, in order to calculate the revised version of I, which is I2. So I2 is 1 plus I. And I is 0.0047, which is 5.65% divided by 12 will give us 0.0047. To the power of C, which is 3, minus 1, and that'll give us I2 of 0.1419. So with those bits of information, so we've got we're calculating the payment, but we've got the future value. We've got the value of I2. We've got the value of N. And so we can plug that into the formula. So the formula is future value equals payment, 1 plus I2 to the power of N minus 1 over I2. We plug all those numbers in, and you will calculate the payment to be $2,294.43. So that's how much Dave would have to invest per month in that. Okay, that's the first thing. The other thing that's asked is how much interest will Dave earn? Well, and I haven't included that. I should have, but let me just make a little space here and I'll include it. I'm going to put it over here. So the payments are $2,294.47 times he made payments quarterly, so he made 100 payments. Okay. So $2,294.47 is the amount of money he paid. He made 100 payments. So if we multiply that, that will come up to $229,447. Okay. Let me just shrink this down a bit. So the interest earned, this is the total payment. Okay. Okay, the total payment we calculate it to be that. We know at the end there's 500,000. Is 500,000. So really the difference between the two, the difference between how much you paid and how much you got, you paid $22,900 in, you got 500,000 back. The difference between it would be about, I'm going to guess it. I'm not going to write in the answer because I don't have my calculator here now. 500,000 minus the 229, and that's about 71. So it's about $271,000 in interest. You see how that's calculated? So that would give us the answer in terms of how much interest did Dave earn. Okay, any questions on that particular type of question? That one's a pretty standard annuity, and there will be one of these on the test. The critical thing that you need to be able to define in the test is, well, besides doing this calculation, is to say, now, is this an ordinary general or ordinary simple? If the payments and the compounds are different, then you have to calculate this value of C and I2. That's the annuity one. Now, another thing that we looked at was annuity due, and annuity due is not that much different, but you have to be able to identify an annuity due. So what is the future value of $350 invested at the beginning of every month for the next 25 years at an interest rate of 7.25%? The key to this problem being an annuity due is it is invested at the beginning of the month. So that's the beginning of the period. And when you have the beginning of the period indicated there, that certainly means that it's annuity due. So how do we calculate that one? Well, again, we know that it's $350 a month invested. It's an annuity due, 25 years, 7.25%, compounded monthly. So we got every month and compounded monthly. So the fact that it's every month and compounded monthly is month and month. So this is an ordinary simple annuity. Ordinary simple annuity. So we don't need to calculate a version of a value of I2. So if it's a simple and ordinary due, what we need to be able to do is just go down through and indicate our numbers here. So the payment is $350 a month. The value of I, well, it's 7.25% divided by 12. And that will give you 0.6042%, which is as a decimal 0.006042. And you can see that over there. The N is 25 years, 12 payments a year. 12 times 25 is 300. And as I say, the compounds per year and the payments per year are the same. So it's an ordinary simple annuity. So we just use this formula for that, the future value. And because it's an annuity due, we multiply it by 1 plus I. So we just plug the numbers into the formula. Well, we got the payment 350. We got the value of I as 0.00604. We got the N, well, that's 25 by 12 minus 1 over the value of I times the 1 plus I. So we just take all that and we add it all up or do the math on it. And that will come out to $296,791.97. So how much interest is earned? Then we have to figure out how much interest is earned. Again, we do the same thing as we did in the last problem. This is the value of it. We put $350 in a month for every month. So it's times 12 for 25 years. So basically, this is how much money we put in. This is how much money we got out. Difference between what we put in and what we got out must be the interest earned. So it is 191,791.97. So again, this is a fairly typical problem, not too complicated, but you need to be able to recognize it, as I say. Is it an ordinary simple or ordinary general? And is it an annuity or an annuity due? Okay, so those are a couple of annuity ones. We also looked at this idea of a repayment schedule. Now, I certainly won't have you do any more than 3 years. It's just too cumbersome. So this one here, though, Paul purchased a new television for $1,250 and will pay for it by making monthly payments for the next 6 months. So in other words, there's 6 iterations here. If the interest rate is 12.25% compounded monthly, construct a full amortization table. Okay, so what we need to be able to do on this first is to figure out what the payment is, and then go ahead and figure out what portion of the payment is interest and what portion is repayment. So in order to do this, we have to, first of all, we know there's 6 payments, or 1 per month, monthly payments for the next 6 months. The interest rate is 12.25 compounded monthly, so we got to take that 12.25 divided by 12. That will give us our monthly rate. As decimal is 0.0102. That will give us the value of I. Our payments per year is 12, and our compounds per year. So this is an ordinary simple annuity that we're looking at. And the value of the TV that we're buying now is $1,250. So that's the present value. So essentially, with those bits of information, we can plug that into the present value formula, and we can use that then to calculate our payment. So $12.50, all this stuff put in, and we'll calculate the payment to be $215.84. So this is the first thing we need to do, is calculate the payment. The second thing we need to do is build our table. So our table starts off with $1,250 owing. The payment of $215.84 is made. In order to calculate the interest, all we need to do is to take the $1,250 and multiply it by the interest. So the year interest is 0.012. So that will come up to $12.76. The difference between $215 minus the amount of interest that was paid would give you how much is paid in repayment, $203.08. So this one and this one added together will come up to $215.84. We subtract $203.08, which is the principal repayment, off the original amount, which is $1,250, and that will give us the ending balance there. And then that ending balance in this one becomes the beginning balance for the next payment. Again, the payment is $215. Calculate the interest, which is on the balance, times that will give us the interest. This minus this will give you this. And this payment minus the initial amount, the outstanding principal, will give us this. We go through this iteration process 6 times, and we know we got it done right when the last comes out as 0. In other words, the unpaid balance will come out at 0 in the prescribed end. So it says, construct a full amortization table, calculate the total interest paid. Well, how much interest was paid? Well, we just add it all up. We can add up those numbers here, and that'll give us our total interest paid. Okay. And you know, that one's pretty straightforward. This is a bit clumsy doing this, but you know, if you know how to do the first one and the second one, you can do 1,000 more. You're not going to, but once you get the first one and the second one out of the way, it's all the same type of calculation. So it should be pretty straightforward in terms of that. So make sure you look at an example of that. Now I put in mortgages here too. Now in order to make this a little simpler, what I've done on this particular problem is I'm suggesting that a mortgage is usually calculated half yearly. But I'm saying in this particular mortgage, and I've stated it here, that it's compounded monthly. So it's a $200,000 mortgage, 25 years, stated interest rate of 8.9%, but I've said that it's compounded monthly, paid per month and compounded month. That makes it a little simpler. So the present value of the mortgage is $200,000, 25 years. Well, there's 12 payments a year for 25 years, which is 300 payments. The interest rate per year is 8.9%, divided by 12, seeing we got a monthly interest rate, and that comes to a decimal 0.0074. We have our basic formula here that we use, the present value formula. We put the appropriate numbers in, 200,000, the I, value I, the value N, and we can calculate the payment to be $1,664.72. So you can calculate the payment pretty straightforward. So mortgages, again, it's the same as any other repayment. It's just you normally know if it's not stated with regards to the payment schedule or the compounding schedule, mortgages are usually, unless it says otherwise, compounded twice a year. Any questions on any of those? Another topic that we looked at was bonds. Bonds are just investments that we buy for an amount of money, and at the end we get an amount of money back, and they pay dividends or they pay interest payments on a regular schedule. So in this particular case, $1,000 bond bearing an interest rate of 6%, payable semi-annually, is due in 4 years. If money's worth 7%, compounded semi-annually, what's the value of the bond if it's purchased today? So we've got some interesting things here. We know it's a $1,000 bond. The bond has a bearing interest rate of 6%. Now, so $1,000 bond, 6%, that's really straightforward there in terms of the payment. So 6%, that's paid semi-annually, so that's cut in two, so that's 3%. So effectively, this bond pays $30 every 6 months for 4 years. So we can do the math on this here. It's 3% per compound, 4 years. So that's N is a value of 8, 4 times 2. So what do we need to do here? We need to be able to, well, I've drawn out a little timeline. 2 basic parts to this. We got to figure out how much the $1,000 that you're going to get paid at the end is worth today. So you got to bring it back 4 years. You're taking $1,000, bringing it back 4 years to find its value now. And you got a stream of payments of $30 that are paid every 6 months. For 4 years, you want to figure out what is the value of that now. So you bring those back. So effectively, there's 2 parts to this calculation. The promise to pay $1,000, so let's figure out what that is. So we can get the present value formula on that. PV equals FB 1 plus I to minus N. We plug all the numbers in that. We got $1,000 as the future value. The interest rate is 7%. That's the market interest rate. So that's 3.5% per. So hence we got this 0.035 to the minus 8, 4 years times 2 per year. It gives 8. So the present value effectively of that $1,000, how much is it worth right now, is $759.41. That's the first thing we do. The next thing we need to do is think of this stream. The stream, well, it's again 0.35. We're calculate the present value semi-annually for 4 years. So we take the present value formula, we plug all the information into that. So the payment is 30, the interest 0.035, N is 8. Throw all that in. So the present value of the stream of payments is $206.22. We take the present value of the $1,000 when it comes back, plus the present value of the stream payments, add them together. So that gives us the purchase price is $965.63. Any questions on that? So this is a typical problem. You should be aware of the bond. Okay. Another thing that we looked at was sinking funds. Now, a sinking fund is a reverse loan. So effectively, you gather up your money to a desired amount, and then you go buy the product. Question is, how much do you need to put in, and how long do you have in order to gather it up? So here's the case of the town of Gander plans to create a sinking fund for $20,000 by making equal deposits at the end of every 6 months for 4 years. Interest is 6% compounded semi-annually. What is the size of the semi-annual deposit into the fund? What's the total amount deposited into the fund? And what's the total interest in the fund? So there's 3 questions here. So effectively, we want to gather up. The future value is $20,000. It's every 6 months that the payments are made for 4 years, and the interest is 6% compounded semi-annually, so every 6 months. So we got an ordinary simple here. We don't have to do any calculation of I2. So if we take a look at this then, we've got our future value amount, $20,000. We're going to calculate our payment. We got the value I. We know the value I, for example, is 6% divided by 2, which is 3%, which is 0.03. And we got the value of N, where there's 2 per year for the period. So that's 8, seeing it's 4 years. Minus 1 over that. We do the math on that. And the payment that we need to make is $2,249.13. So that's the payment. So the total amount of money that we're actually putting into this is the payment times 8, which is $17,993. We're getting $20,000, so the difference between the $20,000 and $17,993 must be interest, which is $2,006.96. So that's a simple, that's a pretty, the problem looks more daunting than it actually is. You just got to be able to pick the main parts. Any questions on that? Another topic that we looked at was preferred stock. Now, this was a simple, pretty simple topic where we said, okay, we're calculating the value of preferred stock given a dividend and given an interest rate. So we know that stock is $1,000. Oh, it's $100 per share. Dividend rate is 5%, and the required rate of return is 10%. So we know that the dividend is really a perpetuity. So there's a perpetuity formula that we use, where present value of the perpetuity, payment, and the rate. Now, where we've got a situation where we don't know what the present value of perpetuity is. We do know the payment. The payment, for example, is preferred dividend rate is 5% on $100, so that's $5 per share. And we do know the rate is 10%, so 0.10. So that's 5 over 0.0. So the price per share is simply $50. So that's for calculating preferred shares. Any questions on that one? Okay, another thing we looked at was trying to make a decision, and as part of the capital budgeting, trying to make a decision looking for the least cost option for leasing buying. So Delaney can lease an automobile for 5 years at $500 a month, payable at the beginning of each month. So again, a lease payment is usually a beginning of month. So in this case, that is what it says there. So that gives us an idea that it's annuity due. Or she can purchase for $28,000. She can obtain a loan for 9.75% compounded. Should she lease the car, or if or buy the car? Now, considering that the car has a resale value of $5,000. So what we need to do is to think about the lease payment first. The lease payment is a string of payments that's going to go on for 5 years. So it's an annuity. And as I say, it's an annuity due actually for 5 years, $500 a month. The buy option is $28,000 up front now, and you get the equivalent value of $5,000 back at the end. So what we need to do is find the present value of that $5,000 at the preceding interest rate, which is 9.75. We need to get the present value of that back. So there's some calculations that we need to do. First of all, we're going to look at the lease, which is the string of payments. So we know the payment is $500. We don't know the future value. The payments for years 12, compounds for years 12, which is an ordinary simple annuity. Interest rate is 9.75%. So we calculate the value of I there. We take 9.75, divide it by 12. That's 0.0081. So we just throw that into that formula then. We just basically put it into the formula, and you'll notice that it's a 1 plus I. That indicates annuity due when the payments are at the beginning of the period. We know that this is the annuity due formula, so we can throw the numbers in, and we will get a present value of $23,861.80. So that's how much it's going to cost us to lease the car. Okay, effectively, that's the lease. The other option we have is to go buy the thing. So we got to put $28,000 down. We get $5,000 back at the end. So we know the current value of the present value of the cost for the car is $28,000. We need to figure out what the present value of that $5,000 is. So we need to draw that $5,000 back. So we put it in the present value formula. So present value is the future value of $5,000 divided by 1.081, which is the interest rate, times the number of compounds. So this is monthly, so it's 12 times 5, which is 60. And that calculates to be a present value of $3,076. So that $3,076 gets subtracted off the $28,000, and that will be the total cost of the car would be, to buy it is $24,900. The total cost of the car to lease it is $23,800. Well, we're looking for the least cost option. So the least cost option in this particular case is a lease. So we'd recommend leasing the car. So that's how you do those. You're basically comparing two options. Any questions on that?
No.
Okay, I got another example here about something we looked at in the capital budgeting, which is the payback period. Straightforward. So a business requires a maximum payback period of 5 years, expects profits from a $75,000 investment to be $9,000 in the first year, 15 in each of the bunch of the years from 2 to 6, and 26 in year 7 and 8. So we got this timeline type thing that we need to develop. And basically, should we go ahead and invest? Well, here's what I've done here. Again, in this payback period thing, we're not looking at the, we don't look at the time value. That's the problem with payback period. So our profits, I've just listed them down here, 1 through 8. So the cumulative profit, I got to figure out when the cumulative profit actually goes above the $75,000 investment. So we know it happens somewhere between year 5 and 6 because it's $69,000 to $84,000. So it really happens in 5, let's say 5.5 years. But the investment needs to be recovered in 5 years. If we can't do it under 5, we can't do it. So in this case, it's greater than 5. So the basic answer is the investment will not recover in 5 years, so we should not proceed with the investment. That's a pretty straightforward one. There's no calculations involved in that at all. You just got to lay it out and figure out when do we cross that $75,000 payback barrier. And if we do it within the time frame, we agree with proceeding with it. If we can't do it in the time frame, we reject it. In this case, we rejected it. Okay. Another example is an investment opportunity, which we looked at in capital budgeting. The introduction of a new product will require expenditures of $250,000 today, $150,000 in 1 year. The product will then produce profits of $125,000 for the next 5 years. Should the firm proceed in the production of a new product if the investment requires an annual rate of return of 15%? So essentially, we're putting $250,000 up now, $150,000 in year 1. In years 2, 3, 4, and 5, we're getting $125,000 back. And we need to do the present value of anything that's passed now. So essentially, this requires some calculation here. We got to, first of all, from the point of view of what I call part 1, which is how much money we put into it, calculate the value of the investment. So we put $250,000 in right now. So the current value of $250,000, the present value of $250,000 now is $250,000. And then we also have to figure out what is the current value of $150,000 in 1 year's time. So we need to take the present value of $150,000 and bring it back 1 year. 15% is the rate that we use. So at 15%, that means in 1 year, the present value is worth $134.35. We add up the $250 and the $134.35, and that comes to $384.34.78, which is effectively how much money we got to put into it right now. $380,000. That's the value that we got to put into it. The other side of the coin is how much money we get out of it. So we can figure out how much we get out of it because we've got $125,000 for 5 years. So we calculate the present value of the stream of payments from years 2 to 6. In this case, that is a stream for 4 years. So 2, 3, 4, 5, 6. For 5 years, sorry. For 5 years. And so we can get the present value, and we just put it in the present value formula. And that will come to $419,019.09. The problem is that $419,019 is in year 2. So we got to bring it back 1 year in order to get the present value now. We do that. Bring it back 2 years, sorry. We're at 2 years, and it's $317,439. So essentially, that's the value of how much money is going to come in right now, $317. So what we're doing is we're putting $380 out now for a return of $317. And the question is, should we go ahead with that? Well, we're losing money doing it. So we're going to reject the investment. Again, not worried about the decimal places here, because the idea is, should you accept or reject the investment? And effectively, you know, 380 is still a lot more than 319. It's nowhere close. So we reject the investment. The final topic we dealt with is exchange rates. And there will be a question there on exchange rates. So again, you know, here's a typical example. How much will it cost in Canadian dollars to purchase 2,000 euros at a bank that charges 2.2% commission in the transaction? Use the exchange rate of $1 Canadian equals 0.71 euros. So the fact of the matter is that euros are worth more than Canadian dollars in this particular instance, because $1 to 71 euro, 0.71 euros. So in order to calculate this, we could do up a little, we could do it a couple ways here. 1 to a mystery amount is the same as 0.71 to 2,000. We got 2,000 euros, 0.71. We do the math on that. We can cross multiply on this, and we can calculate that x, which is the value, is 2,812.38. So effectively, it's 2,812.38 Canadian. And then it says, okay, the commission is 2.2%. So we just simply take 2.2% of that 2,812.38, which is 61.87. We add that to 2,812.38, and that will give us the total cost of us doing that little exchange will be 2,874.25 Canadian. So that's a typical problem that you would have for that. It won't be too complicated, just very similar to that. So that's what I put together for you, and I will assure you that no fooling around, nothing hidden here, that exam will follow that format. And what I want you to do on that exam is to do exactly as you did on the midterm. That is, work it out on sheets of paper, photograph or PDF the sheets of paper, and send it back to me. No different than the way you've done an assignment. Okay, now that was quick. I wanted to do a quick review so not to get bogged down. But let me think. Oh, can I get my... There I am. Okay, so any questions?
That's good.
Well, okay, here's what I want you guys to do over the next couple of days then. If you got a question for me, let me know. We're not going to meet. This will be our final class. Now, unless you guys want to meet, you know, if collectively together, if there's some issue. But effectively, I want you to take a look at this particular review I've done here. Take a look at those sheets that I've got in the course. The exam is built on top of those sheets. So if you can do those questions, you should be off to the races.